A race against time is underway in the Indian Ocean this morning. This is all to stem an oil spill that some environmentalists are already calling an ecological disaster. A large amount of thick, toxic sludge has so far leaked from a Japanese freighter that ran aground off the island nation of Mauritius back in July. The fear now is that the vessel will break up, spilling the remainder of its cargo and polluting the pristine beaches and coral reefs that have made Mauritius a popular tourist destination.
These are images of the once pristine turquoise waters of Mauritius, now stained black as oil spreads into the Indian Ocean. On July 25th, a Japanese tanker carrying nearly 4,000 tons of fuel was on its way to Brazil from China when it struck the reef on the southeast coast of the island. The ship has since leaked an estimated 1,000 tons of oil.
Suddenly, the animals in Prince William Sound were fighting for their lives.
There were otters that were completely coated with oil, a surf scoter. There were birds flapping in the water that couldn't get airborne because of the oiled feathers and such. It was truly a horrific scene.
Our environment is an extremely beautiful and important thing, and it's absolutely terrible when bad stuff happens to it. Whether that be oil spills in the ocean, contaminated land, or anything that harms the environment, nobody likes when bad stuff happens to it. And absolutely no one likes when animals suffer. So how do we clean this stuff up? How do we clean up an oil spill or make contaminated land uncontaminated? Well, one thing we can do is called bioremediation. Bioremediation is an extremely important and useful metabolic process that we humans use. The process of bioremediation involves bacteria microorganisms that degrade the contaminants in the air, ground, water, or any natural setting. These microorganisms are used to break down contaminants and use the broken down product as energy. How does this process start, you may ask? What do we need present in order for this process to function? Well, the contaminant must be present, as well as the primary electron acceptor. This could be oxygen, nitrate, sulfate, or iron. And finally, the specific microorganism that can degrade the specific contaminant must be present. This process results in the microorganism breaking down the contaminant into small amounts of water, harmless gases like CO2, and energy for itself. The population of the microorganism will grow, but once the contaminant is completely eradicated, the population of the microorganism will fade away. So now we know what is needed and what is created in bioremediation. But what specific processes are underway in order for this to happen? Well, bioremediation involves the production of energy in a redox reaction with microorganisms. These reactions include respiration and other biological functions needed for reproduction and cell maintenance. How do these microorganisms break down these toxic compounds? Well, for example, when these microorganisms are trying to break down oil in water, they break down the large, toxic structure of oil into smaller, less complex, and harmless products like fatty acids, carbon dioxide, and water. The microorganisms produce and use enzymes that speed up the biochemical reactions that break down these pollutants. There are many techniques of bioremediation. Some include biofiltration, which involves the treatment of water in a sewage plant. Biostimulation, which involves the addition of a certain ingredient in order for microorganisms to activate and start working. This process usually is involved in removing toxic substances from the ground. Or bioventing. This technique involves introducing oxygen to an unsaturated zone in soil or water. This will enhance microorganisms and their ability to break down toxic substances. So now that we know the positives of this process, are there any downsides or negatives? The answer is no. Bioremediation produces no harmful byproducts, and it is also an extremely safe and natural process. It's also extremely cost-effective. There are some limits to the process, though. The microorganisms need specific conditions to function, conditions like proper temperature and pH. Another limitation is that not all the toxic substances we want to degrade can be degraded by these microorganisms. Each toxic substance needs a specific microorganism that can degrade it, but sometimes this microorganism that we need doesn't exist. And finally, the process takes time. It isn't super quick. Bioremediation is an extremely useful process. It is extremely safe, cost-effective, and natural. There are very limited downsides, and these downsides could be removed with enough research into the process. I think this process is extremely beneficial to us and the environment as a whole. It helps clean up water sources, creates healthier soil, and improves air quality. It does all these things and is a simple, cost-effective solution to many contaminants in our environment. We should continue to research this process in order to maximize its effectiveness and remove its weaknesses.